reaching every learner with compassion, moving everything with passion, driving everyone with dedication. This is Cabael by Math10.
Good day, my beloved grade 10 students of Cabael City. Welcome back to our meaningful discussion in Mathematics 10. I'm Mom Kristine Cabael, your teacher for today. Are you ready to learn, students? Come and join me as we begin our journey in learning mathematics. Before we start, make sure that you have with you your module in Mathematics 10. That is applying the distance formula to prove some geometric properties, a ball pen, a graphing paper, calculator, and a notebook to write down the relevant information, and of course, make yourself comfortable. Now, before we start our topic for today, let me ask you a question. Can you still recall how to plot points in the Cartesian plane? How about naming the coordinates of those points? To test your prior knowledge on this, let us warm up our minds with the following exercises. Are you ready? Let's begin! Did you get a perfect score? Very good! Remember that the coordinate of points are always written as an ordered pair of the form x and y. The first value corresponds to the x coordinate called the abscissa, while the second is the y coordinate called the ordinate. These coordinates tells us the exact location of each and every point in the Cartesian plane, just like locating places in a map. Let us consider the map of Cabael City. Each and every destination found here in the map represent a point in the XY plane. For example, we can take Samar State University as our point 1, whose coordinates are x sub 1 and y sub 1. Similarly, we can take Cabael City Hall as our point 2, whose coordinates are x sub 2 and y sub 2. The question is, using the coordinates, can we solve for the distance between Samar State University and Cabael City Hall? The answer is yes. Today, you're going to learn about applying distance formula to prove some geometric properties. For our lesson objectives, The students will be able to find the distance between 2 points using the distance formula and apply distance formula in proving properties of some geometric figures. What is distance formula? The distance between point 1 and point 2 is equal to the length of the segment joining these 2 points. We name this segment as segment D. To solve for the length of segment D, we follow the given steps. Step 1. Draw a right triangle wherein segment D is the hypotenuse. To do that, from point 1, we will drop a line perpendicular to y-axis. Likewise, from point 2, we will drop a line perpendicular to x-axis. This is now our right triangle. Step 2. Label the legs of the right triangle. We represent the other two sides of the right triangle as segment A and segment B. Step 3. Apply Pythagorean theorem. Pythagorean theorem states that the square of the hypotenuse is equal to the sum of the square of the length of the other two sides. We can write this as d squared is equal to a squared plus b squared. Step 4. Solve for the horizontal distance or the length of segment A. Basically, since the two lines is parallel to the y-axis, then everything that falls to this line is equal to x of 1, while everything that falls in this line is equal to x of 2. Therefore, to get the length of segment A, we need to subtract x of 1 from x of 2. In symbol, we have A is equal to x of 2 minus x of 1. Step 5. Solve for the vertical distance or the length of segment B. Similarly, since the two lines is parallel to the x-axis, then everything that falls to this line is equal to y sub 1, while everything that falls in this line is equal to y sub 2. Therefore, to get the length of segment B, we need to subtract y sub 1 from y sub 2. Thus, B is equal to y sub 2 minus y sub 1. Step 6. Substitution. Let us now substitute the value of A and B in the equation d squared is equal to a squared plus b squared. First, substitute the value of A. So we have d squared is equal to the square of the quantity x sub 2 minus x sub 1. Next, substitute the value of B. This becomes the square of the quantity y sub 2 minus y sub 1. Step 7. Simplify. Since we are solving for the value of D, we need to extract the square root of both sides of the equation. Our answer is now D is equal to the square root of the square of the quantity x sub 2 minus x sub 1 plus the square of the quantity y sub 2 minus y sub 1. This equation is now what we call distance formula. We can apply this formula in solving for the distance of any two given points whose coordinates are x sub 1, y sub 1, and x sub 2, y sub 2. Let us now apply this formula in solving for the following problems. Problem 1. Plot and solve the distance between the points E, 1 and 1, and R, 2 and 4 in the coordinate plane. Step 1. Sketch the figure. We plot point E, 1 and 1, and point R, 2 and 4 in the Cartesian plane. Then we connect the 2 points to form segment ER. Step 2. List down the given. Our given are x sub 1 is equal to 1, y sub 1 is equal to 1, x sub 2 is equal to 2, and y sub 2 is equal to 4. Step 3. Write down the solution. In our solution, we apply the distance formula. Segment ER is equal to the square root of the square of the quantity x of 2 minus x of 1 plus the square of the quantity y sub 2 minus y sub 1. By substituting the given in the formula, we have segment ER is equal to the square root of the square of the quantity 2 minus 1 plus the square of the quantity 4 minus 1. Simplifying it further, 2 minus 1 is equal to 1, and 4 minus 1 is equal to 3. Square of 1 is 1, and square of 3 is 9. Add, square root of 1 plus 9 is equal to the square root of 10. Therefore, the distance between points E and R is square root of 10. Problem 2. Show that the figure formed when points L, -4 and 4, O, 3 and 9, V, 8 and 2, E, 1 and -3 are connected consecutively as a square. Then find its perimeter. Our given are x of 1 is equal to -4, y sub 1 is equal to 4, x of 2 is equal to 3, y sub 2 is equal to 9, x of 3 is equal to 8, y sub 3 is equal to 2, x sub 4 is equal to 1, and y sub 4 is equal to -3. In this problem, we are going to prove that the figure formed is a square. Then we need to solve its perimeter. To do this, we need to undergo 3 important steps. Step 1. Plot the given points on the coordinate plane. First point has a coordinate of -4 and 4. So point L is in quadrant 2. Second point has a coordinate of 3 and 9. So point O is in quadrant 1. Third point has a coordinate of 8 and 2. So point V is in quadrant 1. Last point has a coordinate of 1 and -3. So point E is in quadrant 4. These are our points. Now, connect the points to form a figure. We connect points L to O, points O to V, points V to E, and point E to L. Step 2. Show that the given figure is a square. Since the figure formed as a square, we need to show that all the sides are equal in length and all angles are right angles. First, let us show that all sides of the figure are equal. To do that, we need to apply the distance formula. To solve for the length of segment LO, segment OV, segment VE, and segment EL to test if it is equal. To solve for the length of segment LO, use the points L, -4 and 4, and O, 3 and 9. Since it is in the first and second point, our formula is segment LO is equal to the square root of the square of the quantity x of 2 minus x of 1 plus the square of the quantity y sub 2 minus y sub 1. By substitution, we have segment LO is equal to the square root of the square of the quantity 3 minus -4 plus the square of the quantity 9 minus 4. Simplifying it further, 3 minus -4 is equal to 7, and 9 minus 4 is equal to 5. Square of 7 is equal to 49, and square of 5 is equal to 25. Add, square root of 49 plus 25 is equal to the square root of 74. Therefore, the length of segment LO is square root of 74 units. To solve the length of segment OV, use the points O, 3 and 9, and point V, 8 and 2. Since it is the second and third point, our formula is segment OV is equal to the square root of the square of the quantity x of 3 minus x of 2 plus the square of the quantity y 3 minus y sub 2. By substitution, we have segment OV is equal to the square root of the square of the quantity 8 minus 3 plus the square of the quantity 2 minus 9. Simplifying it further, 8 minus 3 is equal to 5, and 2 minus 9 is equal to negative 7. Square of 5 is 25, and square of negative 7 is 49. Add, square root of 25 plus 49 is equal to square root of 74. Therefore, the length of segment OV is square root of 74 units. To solve the length of segment VE, use the points V, 8 and 2, and E, 1 and negative 3. Since it is the third and fourth point, our formula is segment VE is equal to the square root of the square of the quantity x sub 4 minus x sub 3 plus the square of the quantity y sub 4 minus y sub 3. By substitution, we have segment VE is equal to the square root of the quantity 1 minus 8 plus the square of the quantity negative 3 minus 2. Simplifying it further, 1 minus 8 is equal to negative 7, and negative 3 minus 2 is equal to negative 5. Square of negative 7 is 49, and square of negative 5 is 25. Add, square root of 49 plus 25 is equal to square root of 74. Therefore, the length of segment VE is square root of 74 units. To solve the length of segment EL, use the points E, 1 and negative 3, and L, negative 4 and 4. Since it is the first and fourth point, our formula is segment EL is equal to the square root of the quantity x sub 4 minus x sub 1 plus the square of the quantity y sub 4 minus y sub 1. By substitution, we have segment EL is equal to the square root of the quantity negative 4 minus 1 plus the square of the quantity 4 minus negative 3. Simplifying it further, negative 4 minus 1 is equal to negative 5, and 4 minus negative 3 is equal to 7. Square of negative 5 is 25, and square of 7 is 49. Add, square root of 25 plus 49 is equal to the square root of 74. Therefore, the length of segment EL is square root of 74 units. Since segment LO, segment OV, segment VE, and segment EL have the same length, therefore, all sides of the figure are equal. Let us now prove that the figure has 4 right angles. Take note that if two lines are perpendicular, then they form a right angle, and their slopes are negative reciprocal of each other. Hence, we need to find the slope of each side. To do that, we will use the formula for slope. That is, m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. From this, we will test if each consecutive sides are perpendicular, and we will prove that angle L, angle O, angle V, and angle E are right angles. By applying the formula, we have the slope of segment LO. Use the points L, negative 4 and 4, and O, 3 and 9. Slope of segment LO is equal to 9 minus 4 over 3 minus negative 4 is equal to 5 over 7. The slope of segment LO is 5 over 7. The slope of segment OV, use point O, 3 and 9, and point V, 8 and 2. The slope of segment OV is equal to 2 minus 9 over 8 minus 3. That is equal to negative 7 over 5. The slope of segment OV is negative 7 over 5. The slope of segment VE, use point V, 8 and 2, and point E, 1 and negative 3. Slope of segment VE is equal to negative 3 minus 2 over 1 minus 8. That is equal to 5 over 7. The slope of segment VE is 5 over 7. The slope of segment EL, use point E 1 and negative 3 and point L negative 4 and 4. The slope of segment EL is equal to 4 minus negative 3 over negative 4 minus 1. That is equal to negative 7 over 5. The slope of segment EL is negative 7 over 5. Based from the computed slopes of each segment, we can conclude the following. Since the slope of segment LO and segment OV are negative reciprocal of each other, then the angle O is a right angle. Since the slope of segment OV and segment VE are negative reciprocal of each other, then angle V is a right angle. Since the slope of segment VE and segment EL are negative reciprocal of each other, then angle E is a right angle. Since the slope of segment EL and segment LO are negative reciprocal of each other, then the angle L is a right angle. Since all the sides of the figure are congruent and all the angles are right angles, then quadrilateral LOVE is a square. Step 3. Solve the perimeter. Perimeter is defined as the sum of the length of the sides of a polygon. To solve for the perimeter, we use the formula P is equal to 4S, where S is the side of the square. By substitution, we have P is equal to 4 times the square root of 74. Using the calculator, P is approximately 34.409,000 units. Therefore, the perimeter of the square is approximately 34.409,000 units. Example 3. Prove that the two sides of an isosceles triangle are congruent. Given triangle ABI with sides segment AB, segment IB, and segment IA. Prove that segment AB is congruent to segment IB. To prove this, let us follow the given steps. Step 1. Place triangle ABI on the coordinate plane. In placing the geometric figure in the XY plane, you need to take note of the following. First, the base or segment IA should coincide the x-axis. Next, the apex or point B should lie in the y-axis. Step 2. Label the coordinate points. In the absence of numerical value, we need to assign variables in the figure appropriately. Since the figure is an isosceles triangle, when we draw a line from the apex or point B perpendicular to the base, the segment formed divides the base into two equal parts. Thus, if we label the segment as A, the other side is also equal to A. Since the altitude of the triangle is unknown, we can label it as B. Next, we need to write the coordinates of point A, B, and I. Since the measure of this segment is A and it lies in the positive x-axis, then the coordinate of point I is A and 0. Next, since the measure of this segment is A and it lies in the negative x-axis, then the coordinate of point A is negative A and 0. Lastly, since the measure of the altitude is B and it lies in the positive y-axis, then the coordinate of point B is 0 and B. Step 3. Solve for the length of segment AB and segment IB. To solve for segment AB, we use the coordinates of point A and B. Our formula is segment AB is equal to the square root of the square of the quantity x sub 2 minus x sub 1 plus the square of the quantity y sub 2 minus y sub 1. By substitution, we have segment AB is equal to the square root of the square of the quantity negative a minus 0 plus the square of the quantity 0 minus b. Simplifying, the equation becomes segment AB is equal to the square root of a squared plus b squared. To solve for segment IB, we use the coordinates of point I and B. Our formula is segment IB is equal to the square root of the square of the quantity x sub 2 minus x sub 1 plus the square of the quantity y sub 2 minus y sub 1. By substitution, we have segment IB is equal to the square root of the square of the quantity 0 minus a plus the square of the quantity b minus 0. Simplifying, the equation becomes segment IB is equal to the square root of a squared plus b squared. Since segment AB is equal to the square root of a squared plus b squared, and segment IB is equal to the square root of a squared plus b squared, by substitution, we can say that segment AB is equal to segment IB. Therefore, triangle ABI is an isosceles triangle. And now, to explain our ideas about the words that you have encountered at this point in time, let us go through the important terms that we have learned today. The distance d between points A, x sub 1 and y sub 1, and B, x sub 2, y sub 2 may found using the formula d is equal to the square root of the square of the quantity x sub 2 minus x sub 1 plus the square of the quantity y sub 2 minus y sub 1. Distance formula could be used in proving some properties of geometric figures. However, the correctness of your proof greatly depends on how accurate you have sketched the figure in the xy plane. Here are some suggestions to help you place figures for your proof. Number 1. Use the origin of the coordinate plane as vertex or the center of the figure. For example, when you place the square in the xy plane, you need to ensure that either one of its vertices coincides to its origin. In this case, we will take this vertex. So, when we move this figure in the Cartesian plane, it will look like this. Next, since circle has no vertex, we simply need to coincide its center to the origin of the xy plane. The figure should look like this. Remember, drawing your figure like this in the Cartesian plane is a no in making proofs. It is because none of these vertices coincide with the origin. Number 2. Place at least one side of the figure on the coordinate axis, either the x-axis or the y-axis. Example, in this figure, we draw the square in such a way that its two sides coincide in both axes. Additionally, we can also draw the figure wherein only one of its sides coincide either x or y axis. In the contrary, when none of the sides of the figure coincide with the axis, that is incorrect. Number 3. Keep the figure within the first quadrant if possible. Take note that the Cartesian coordinate plane consists of 4 quadrants: Quadrant 1, Quadrant 2, Quadrant 3, and Quadrant 4. However, since the coordinates under the first quadrant are both positive, if possible, geometric figures should be drawn in this quadrant. This will pave way to a much easier solutions and computations. Now, let us take a look at the figure. Observe that when we draw the right triangle in the first quadrant, neither of its three vertices coincides the origin, and none of its sides coincides either the x or y axis. Since it is not possible, we can just simply sketch the figure in quadrant 2, quadrant 3, or quadrant 4. Number 4. Use coordinates that makes computation as simple as possible. If you can still remember, when you draw a figure as a basis of your proof, one of the vertex of the figure should coincide the origin. As a result, we take the origin as our starting point. From this point, we draw the side in such a way that this segment lies in the x-axis or in y-axis. Lastly, we continue drawing the figure in the first quadrant. The reason behind this is for you to be able to come up with simple coordinates. Since this point is at the origin, then its coordinate is 0 and 0. If the length of this segment is r, and this point lies in the x-axis, then the coordinate of the x-intercept is r and 0. Lastly, if the length of this segment is s, and this point lies in the y-axis, then the coordinate of this point is 0s. Here it ends again our discussion. It has been a wonderful time being with you, our dear students. Join me again in our next episode for a new learning opportunity where studying math is so fun and easy. I am your teacher, Ma'am Kristine. Stay at home and God bless everyone. And always remember that we heal as one, we learn as one through Bayanihan.
Ang ating radio and television-based instruction ay naisakatuparan dahil sa walang sawang pagsuporta ng ating City Mayor, Honorable Dexter Uy, ang ating Vice Mayor, Coefredo Tikwa Uy, at ng buong sangguniang panglungsod ng Catbalogan na pinangungunahan ni Councilor Honorable Step Uy-Tan. Kaya, ang DepEd Catbalogan City Division ay taos-pusong nagpapasalamat sa malaking suporta ng City LGU sa ating mga mag-aaral. Muli, maraming salamat sa inyong walang sawang pagsuporta.